Hello! How to model and validate embedded systems functional requirements with Stimulus. How, using simulation, can you observe the specified system behavior, even if you've written only a few textual requirements? Let's take a very simple example. A heating system with a heat command and the measured temperature. Here are two textual requirements. One describes the initial condition for the variable temperature. The other specifies that when the heating mode is on, well, the temperature should increase. The running modes are defined in the state machine. The system mode changes from off to on depending on the heat command. Well, that's it. You're ready to simulate. In fact, just one sentence would be enough. Let's launch the simulator and do 10 steps and 10 more steps. And you can see the temperature rising when the heat variable, a boolean, is true. Here, on the contrary, the temperature drops when the boolean is false. You could wonder why at this point the temperature increases but we do not heat. Why? Let's go back to the model. In fact, the requirements indicate what we should do when the heater is on, but nothing is indicated when the heater is off. So let's add the missing requirement. It's the elicitation process. To create textual requirements, you use a library with operators. Here, the temporal operators. The library can be enriched as you wish. Let's drag and drop the when operator. Write that the mode is off. Then we want to state that the temperature must decrease. Decreasing is the evolution of a signal. We drag and drop the decreasing operator, and we just fetch the temp variable. That's it. We've added the missing requirement. So now you can simulate again. We repeat the same 20 steps. The tool can reproduce the exact same sequence. And you can see this time that the system has been constrained by additional requirement at the precise point where the temperature started to rise. And so now the temperature continues to drop nicely. This is one scenario among many possible ones. Just to reset and play. You generate a new scenario satisfying the requirements. You can generate as many scenarios as desired. All of them are possible behaviors of the specified system. We mentioned two variables in this model. They are defined in the glossary. We have heat, a boolean, and temperature, a real. Many available data types can be combined. You can also define test scenario or use cases using state machines or other textual sentences. In this example, we do not heat for a period between 10 and 15 seconds, then we heat until we reach 20 degrees, and then we stop. With this block diagram, you can apply this test case to the system specification. When you simulate, you can see the scenario defined to test the requirements. The temperature starts somewhere between 5 and 15 degrees, the temperature drops, and after 10 to 15 seconds, the heater starts. You can also generate a lot of scenarios, for instance 10, which show that the tool can compute the envelope of possible behavior. And within this envelope, it will generate scenarios which all comply with the specification. Some of the generated scenarios, like this one, show that there's a conflict between requirements. Conflict that is automatically detected by Stimulus. To summarize, Stimulus enables you to describe requirement in a textual language, close to the natural language. Design test scenario that includes probability, debug them jointly using simulation, and finally, generate easily numerous test vectors that can be applied to the actual system once developed. Stimulus is the first tool that allows you to write only one textual requirement and start simulating right away. This tool was very quick. You can still have many questions about Stimulus expression power, the scalability, the multi-user support, requirements traceability, or users' feedback. Please contact AlgoSim with many other data we would like to share with you.